Hi, lesson 8-7, slope-intercept form. Math is a lot of patterns. Probably one of the best quotes is that math is the science of patterns. We're going to go from patterns to coming up with equations. We're going to start off with something like this. Started this in the class the other day. Let's suppose you have a pattern, right? No big deal. 5, 6, 7, 8, 9, 10, da 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 da. There's a pattern. Most of the kids, hey, well, I can figure out the next number in the pattern. The question is, can you come up with the rule, the relationship? In math, we call that the function. Can you come up with the rule that describes this? Instead of writing them all out, we're going to come up with a rule that tells you how to get any of the numbers, any of the terms. The key is, and the key is always, how much does it go up? Let's see. These go up by 1. Well, that's easy to see. They go up by 1. How do you terminate that? That's the rate of change. It changes 1 every time. Now, I'd like to be able to do several things with this. I want the rule. I could put this in a box, a chart. Here's the thing that most kids don't get. It's kind of simple. The first number is 5. The second number is 6. Third, fourth, fifth, sixth, etc. So what's the rule? Well, how do you get from 1 to 5? You add 4. How do you get from 2 to 6? Add 4. 3 to 7. The rule is add 4. You always add 4. The first number we always call x because someone, Descartes, way back in the 1700s, whatever, used x's and y's. Welcome to math called algebra. X plus 4. Input, first number. Rule, add 4 to that number. 1, add 4. 2, add 4. 3, add 4. Input, output. In math terms, we call that the domain and the range. I'd rather call it input and output. This is a way to describe this pattern. Whatever number you start with, you always add 4. We can also graph that. Students should be able to tell you, we graph because then we see it. We see the relationship. 1 gives you 5. Over first. First we walk this earth, then we either go up or down. In a hotel, you walk on the floor, then you get in an elevator, you go up or down. First you do the horizontal, first you crawl, then you stand up. I don't care how you want to remember it. 1, 5. Over 2, up 6. Up 4 over, up 8. 5, 9, etc. At this point in pre-algebra, the graphs you're going to make are always lines. Always. We're not going to graph anything else until next year in Algebra 1. It's a line. This line has 2 components. What's the most important point on this line? The most important point is called the y-intercept. Y-intercept. Kind of like the interception. You catch it, you intercept. Right here at 4. It also tells you something else. There's 2 components, where it crosses the y-axis and then how it changes. Now, I already erased it, but it had a rate of change of 1. That 1, the number in front of the x term, tells you that it goes up 1 every time. Every time it does. Up 1, up 1, up 1, up 1. All right? In math terms on the graph, it's up 1 over 1. Rise over run. Y's over x's. Vertical over horizontal. How much up, how far sideways. It's a rate of change. It has a slope of 1. It has a y-intercept of 4. You get those 2 pieces of data. I know where I start and I know how I change. I start at 4 right here and I go up 1 over 1 all the time. The trouble is this is way too simple. This one's pretty nice, but it's a good one to start with. Let's do a little bit more complicated one, okay? Suppose 1 goes with 3. 2 goes with 5. 3 goes with 7. 4 goes with 9, etc. They don't go up by 1. They go up by 2. Every time you make a jump, you go up by 2. Here's a jump of 2, here's a jump of 2, here's a jump of 2. Every time I go up 1, it's a jump of 2. That's slope. Jump of 2 over 1. Now we hardly ever write 2 over 1 because it's just easier to write 2. Where does it cross the where does it cross the y-axis? Let's see. You want me to graph it? If I graph it, 1 gives you 3, 2 gives you 5, 3 gives you 7, 4 gives you 9. By the way, if you want a good graphing program, free. GeoGebra. G-E-O-G-E-B-R-A. GeoGebra. It's kind of like geometry and algebra. Free download, www.geogebra.org. Maybe it's .com, I don't know. Look for GeoGebra. G-E-O-G-E-B-R-A. Combination of geometry. Free graphing program. Free. Lots of power. Lots of YouTube videos on that also. It'll help you graph. It doesn't cross at 3. It doesn't cross at 3, even with my bad graph. If I went back one more, it'd have to cross at 2, or at 1, I mean. This is the equation that tells me all about this. Let's see. 1 times 2, 2 plus 1, answer 3. 2 times 2, 4 plus 1, 5, check. 3 times 2, 6 plus 1, 7. It divides everything. It defines the whole problem. Whatever number you have, input a number, double it, add 1. Double it, add 1. Slope-intercept. The trouble with some of the problems out of the book has been that they always haven't had it in the right form. Let's say it's 2x plus y equals 5. First number doubled, plus a second number, gives you a total of 5. Let's see, what kind of numbers could that be? Students get a very difficult time sometimes because they think, well, there's like one answer. There's one answer that works. No, there's lots of answers. Like for instance, in math classes for the rest of all the way through calculus, you can always make what's called a T-chart. T, put in a number for x. The best number to put in is 0. It's easy to work with. 0 times 2 is 0. What do you add to 0 to get an answer of 5? Well, y has to be 5. Put a number 1 in there. 2 times 1 is 2. What do you add to 2 to get 5? 3. 2. 2 times 2, 4. Plus 1, got to have a 1 there. Interesting thing happens at 3. 3 times 2, 6. But wait a minute, 6 plus what gives you 5? Oh, it's got to be negative. Let's graph it. I just made a mention that it always turns out to be a line. Well, it's got to be a line. 0, 5, 0, 5, none left or right, straight up 5. 1, 3, 2, 1, 3, negative 1. Oh, wait a minute. This one goes down. That's because the slope isn't 2. The slope is not 2. Slope-intercept form is y equals mx plus b through Algebra 1, through Algebra 2, through geometry, through calculus. Y equals mx plus b. One of my former students is a freshman at UNL. First day of calculus, slope-intercept form. Better know it. Very crucial for understanding how things change. We just did a graph today about the prison population in Nebraska. It was pretty much not one of those. I wish the prison population was going down. It's actually going up. Going to cause some problems, some decisions. You have to get this all by itself. Y. Y variable. How do you get rid of the 2x? And don't tell me you just erase it. That doesn't work. Opposite of 2x is subtract 2x. Subtract 2x. How do you take 5, subtract 2x? Is that 3? Anybody there? No, it's not 3. It's negative 2x plus 5. Well, why didn't I put 5 minus 2x? Because it's y equals mx plus b. What is the intercept? 0, 5. That's a crucial point, very crucial point. That's where it all begins. From there it goes down 2 over 1, down 2 over 1, down 2 over 1. It's a way to represent ideas, changes. Businesses use this. Engineering, scientists, all kinds of people use it. Even organizations like schools, hospitals, churches. Why? Because we want to graph. We want to see what's going. What's the future like? Is it going up? Is it going down? How much? How far? How fast? Every time you go 1 year over, you're dropping 2 in case like that. Slope-intercept form. If you have it in this form, there's the slope, rise over run. In this case, it's -2 over 1. And it always starts at 5. On the y-axis, not the x-axis. You get that mastered, Algebra 1, Algebra 2, even geometry will be smooth sailing.